Before we get started with the deep dive, let's have a look at the overview of this workflow which is provided by the Visual Machine Awareness product suite. The ecosystem we see here is based around enhancing processes that require operators and quality analysts on the shop floor today to use their eyes. It consists of, in the first step, a workpiece, an object, or a tool to be monitored by the system. In the second step, we connect an IP-based camera to SINUMERIK Edge. And in a third step, you can see that we provide model training data in order to create AI models, which can then be provided back to the Edge device directly. After this step is complete, we can also enable integration with industrial controllers, and we can use these models we've created to realize multiple types of use cases. This workflow can be applied within a machine itself, within an automation cell, or in shop floor environments. And the key applications that are enabled by this ecosystem are Manage My AI in the cloud environment, which enables model creation and management directly, and also two edge applications, Protect My Machine Setup, which focuses on workpiece monitoring and object detection, and Analyze MyWorkpiece Toolcheck, focusing on operations monitoring or quality analysis, specifically with regards to toolwear. In more detail, here's an overview of the different use cases which are covered by each application. Protect My Machine Setup mentions workpiece process monitoring and identification, for an object detection and environment confirmation, and also quality analysis or completeness checks. Analyze MyWorkpiece Toolcheck focuses on toolwear monitoring, and Manage My AI enables a cloud-based AI model creation platform. As promised, today we'll be taking a look at Analyze MyWorkpiece Toolcheck and Manage My AI. Before we get started with the usage of the applications, it's important that we run through a few easy prerequisites in terms of the configuration for the apps to make sure that we have everything set up correctly and that we're ready to use the apps in the correct way. The first step is to navigate to your MindSphere tenant. Here's where we have all of our cloud-based management for SINUMERIK Edge applications and also for our visual machine awareness apps as well. You can see here that the first step is to select the Edge applications and make sure that they're installed on our Edge device correctly. To do this, we can navigate to Manage My SINUMERIK Edge App Management. We click on the app icon, and we're taken to our app management page. Here, we can simply type in the machine that we want to make changes to. We can select our device directly, and we'll see which Edge applications we've already installed, if any, and if we need to install the relevant applications, we can go here to New Application. You can always find the details in the documentation about which apps are required, but for example, using visual machine awareness apps, you need to install Protect My Machine Setup and Analyze MyWorkpiece Toolcheck. Always check to make sure that you're using the latest available version in your tenant. By clicking this button, New Application, we can easily navigate to see the relevant application names and versions which are available for us to download. For example, also Analyze MyWorkpiece Toolcheck can be seen here. As we've already installed the applications on this device, a few things of note. Very important here is that we can see we need to have our application instances running when we use the devices. We can also remove the app instances or configure their setup as well. But most importantly here is we want to make sure that we are reviewing the additional documents. Please be sure to download and keep these documents in a handy spot so that you can reference them throughout the configuration process. They are particularly helpful, especially the first time going through the process. So now that we have our applications installed, we also need to make sure that we have our cloud-based application, Manage My AI, available in our tenant. To do this, once you've purchased the application, it's been provisioned to your tenant, you should see this icon, Manage My AI, appear within your tenant. As long as you have the user rights set up within the MindSphere application, you will be able to see this icon directly. So just make sure it's available before you start the process. Now that we've confirmed that all of our applications are available and good to go, we'll navigate back to our relevant edge device for today, and we'll have a look at the sensor adapter. So configuring the sensor adapter is the first step in setting up a camera to work directly with our SINUMERIK Edge device. There's two things to monitor in this process. The first is, from the additional documentation, we have two very helpful manuals for both of the Edge apps. We have a camera configuration manual for Protect My Machine setup, and also for Analyze MyWorkpiece tool check. These manuals are very similar, and you can reference them individually depending on which application you're installing. But this workflow gives you an overview firstly of how to install the sensor adapter application as we've just reviewed. And if you scroll further down to the next section, you can also see here which configuration steps you need to take. So here you can see all the configuration editing steps. Particularly important here is that you can configure one camera directly by making direct changes to the configuration log, or you can configure your application to support two cameras. You can see all the notes and also sample configurations directly here in the documentation. And if we look back to our MindSphere instance, we can click on this configuration directly, and we'll see that it loads all the details as we saw in the documentation. So we can make any changes that we need to here following the documentation directly, and we can enable one or two cameras. Now that the sensor adapter is set up, I wanted to shortly give you an overview of how to reference our documentation and best practices to configure the IP camera directly. The best tips we have for these options are found in the operating manual. We have separate operating manuals for Protect My Machine setup and also for Analyze MyWorkpiece tool check that come with really helpful tips about how to set up the camera, configure it correctly, and make sure that you're ready to gather data once you've installed the apps on the shop floor. For example, you can look here to camera installation, and you can find a helpful list of all the specifications, what we recommend for the camera directly, and also cameras which we have used in our testing. You can also find details about what different protective housings offer you, depending on if you install the camera within a machine tool or near it. And you can also, for example, here see details about how to install the camera if you're using Protect My Machine setup for one workpiece, where the camera can be positioned, how to connect it to the Edge device, and what a sample configuration looks like. We also provide options concerning more workpiece examples. In this case, you can find very similar and helpful details for Analyze MyWorkpiece tool check as well. If you navigate to camera installation, again, you can see here our specification and recommendations for this particular use case. It comes with a unique guideline, which is different and specific to the Analyze MyWorkpiece tool check workflow. So here you can see a wide range of recommendations concerning how to position the camera, what kinds of defects to look for, how to build your use cases effectively, and also how to reduce issues coming from reflections or lighting problems that may occur using a microscopic camera. We also have recommendations for enclosures and housings in this use case as well. And you can always reference this information to ensure that your camera is set up correctly and ready to go for the use cases, which you can cover in both of the applications. Once the camera is set up and you're satisfied with the implementation that you have, there's one more important step which needs to be monitored, and that is the configuration of an MGUD variable within SINUMERIK so that you can remotely and directly access the application itself through G-code. To do this, we offer the installation manual, which, among other steps, offers multiple configuration approaches that you can reference here. For example, if we go to Section 5, Configuration, this step will tell us how to configure the SINUMERIK adapter directly. Important here is to note that you need to install an additional application if you want to call the application on the Edge device from your SINUMERIK device directly. So it's called SINUMERIK adapter, and you can follow these simple steps listed here to install the application, and then also to set up your MGUD variables, which are relevant for controlling the application directly from the SINUMERIK controller. For example, Protect My Machine Setup uses these two examples that you can set up in this procedure. And of course, Analyze MyWorkpiece Toolcheck also offers an overview of these two options. You can see here again the instructions for installing the SINUMERIK adapter in MindSphere, and also the route to create these two variables on the SINUMERIK side, now specific to Analyze MyWorkpiece Toolcheck. The last tip, and also included in the documentation with your Edge device, is before you set up the device for the first time, be sure to check the latest README that we've published with the last version, as this can provide you with new tips and hints, and also can support you with any restrictions that may be available in upcoming versions of the app. You can see we provide individual READMEs for both of the applications, and of course you can always contact your Siemens hotline representative if you have any questions about how to proceed. So, now that we've completed our prerequisite steps, it's time to dive into the application. Now we're going to have a look at the SINUMERIK Edge application, Analyze MyWorkpiece Toolcheck. You can see here we're looking directly at the SINUMERIK Edge application and the browser setup. Before we get started with the app itself, let's look at a few essentials. In the top right hand corner, you can configure your language. Also important as an administrative user is to review the settings. Here you can decide which types of data are stored in the application to ensure your compliance with GDPR regulations. For navigating the application, you can click through any of the icons, or you can also toggle through the sidebar on the left-hand side here. Looking at the many icons themselves, we have here a few options. The Online Analytics page enables the live stream and view directly into the machine. Create New Models is our process for enabling data acquisition for new models directly in the app. We can also manage models that we've already created. The reporting page shows us an overview of all the results that we've triggered through the application, where we can also export details. And dashboarding enables a visual overview of all the results that we have so far. In a first step, let's focus on creating a new sample model. To do this, I click on Create New Models. In the first step here, the application will ask you to select your use case. As we're using Analyze MyWorkpiece Toolcheck, the use case toolwear analysis is shown. I can click here on this option, and I can accept. Now a wizard will walk me through a workflow to collect data for a particular use case. In this example, I first need to select the camera that I will associate my data with. Here you can see a live stream of the image itself. So here we're looking directly at a tool insert, which shows an example of a broken tool. In this case, if we don't have optimal conditions or lighting, we can also make small adjustments here and use this page to ensure that our live stream is correct and that we have the right view on the tool ahead of time. Once we're satisfied with the view that we have, we can accept this camera association. This will now move us towards the next step. On this page, we can begin to create and make classes for our model directly. A few things to note here. First, the number of images is configurable here in the bottom right-hand corner. When I press the edit icon, I can change and adjust the number of images that I require up to 100 images in one total class. In this example, we'll take just 5 images to show an overview of how the application is functioning. But as stated, you may collect up to 100 images at one time. It's recommended that per class you collect at least 200 individual images as you perform the data acquisition process. Now to begin, we see here on the right a live stream of the camera itself. What we can do in this case is define a new toolwear demo. For example, toolwear demo 3. This could apply to any use case that you want to create as a user of the application. I can then save the name of the model by clicking Save here. In the next step, I can add individual classes to my model directly. In this case, for example, we can see that the tool is clearly broken, but it may be that I want to collect different kinds of training data within a class so that I can classify a number of different results. So for example, I might define a few different options here. In the first section, let's say we want to collect data of a broken tool. I can select broken, accept, and close. And now, in order to collect snapshots for this exact image, I just need to press this camera button directly, and it will trigger the data acquisition process. Once the data has been collected, I receive this confirmation message, ensuring that I've actually gathered the training data. Here I can update the name again, accept, and close. You can also see some helpful tips for collecting data here at the bottom of the page. These are also related to the manual directly, but you can see here a number of steps for adjusting the image and also obtaining new data sets. It's important to focus on aspects here such as the zoom ratio and the focus of the camera to ensure that you can see clear differences on the tool itself, and also try to avoid blurriness in the focus point of the image as much as possible. Important here as well is having different lighting conditions throughout your data acquisition process and ensuring that you are focusing on the tool wear in small variations as you would like to create your use case. In this example, we could also add different classes. For example, if the tool was not completely broken, we could add a label for 70%, for example. You can see here we can add a number of different classes, and in this case we simply need to swap out the tool for examples of a tool in a different condition and take more snapshots of this image accordingly. This is just an example process of how you can use the application to collect data based on qualified training images that you're using as a part of the process. It's completely configurable and customizable, so you can tailor it to suit your needs however you like. In this case, let's say we continue with this data of the broken image, knowing that we would need to collect more data in the future in order to get a good result for this tool directly. Once we're ready to submit our first set of data, we can go to Submit. Here we receive a confirmation and a report of what we've worked on, toolwear demo 3, and these images and classes are now confirmed. We can either download the data directly from the edge device, which will give us the image files locally here on our device, or we can confirm and submit. This will send the data to the Manage My AI application in MindSphere. Here we will receive a confirmation. It's important to note that once we send the files to MindSphere, they will be removed from the edge device, so as we send them, then they will be available in MindSphere. We can approve this process, and the data will quickly be uploaded to MindSphere. Now we can navigate over to our model management page, and we can see that this new model we've created, toolwear demo 3, with camera 1, is now in the submitting phase, meaning that the data is being uploaded directly. If we want to go back and make additional changes or updates to this model, we can simply click on the Edit button here, and it will refer us back to exactly the same model and positioning that we used before. Here we can continue to edit the classes and collect more data and send it back to exactly this model to enhance and continue the updates of this model over time. In the next step, we'll move to Manage My AI to see the details. Now that we've successfully uploaded our data into the MindSphere application Manage My AI, we're going to look back at the MindSphere tenant and use two applications to manage the data, get an overview of our models, initiate model training, and also to access a finished model all out of this cloud infrastructure. The two applications we'll be using are the Fleet Manager, which is available as a standard app from MindSphere, and also Manage My AI, which relates to the edge applications we've reviewed so far. So in the first step, we're going to open up Fleet Manager to get an overview of the data. You can see here that within the MindSphere Fleet Manager, we can search for our industrial edge device here, so SINUMERIK edge asset that we've been using before, And with this device, we can also filter for a number of different files in place here. You'll see within the Fleet Manager protocol a mixture of log files, image files that you've uploaded directly from your edge device, and also .model files, which are the completed AI models generated by the application Manage My AI. In this case, for example, if we filter for image-based files or .png, we can see an example of all the recently uploaded images that are available for our viewing again in MindSphere. This is important because you can always access the data that you've uploaded to MindSphere from your edge devices through one singular platform. You can simply select as many of the options as you'd like and download them directly to your device. For example, once you have the images, you can then view them locally, as you can see here with this example. Another aspect of the Fleet Manager which you can look at through the filtering is the models themselves directly. So here you will also find completed models once they're available. But in order to get to these, we first need to go back to the Manage My AI application to understand how we generate these models. So from here we go back to the Launchpad and we click on the application Manage My AI. This brings us here to our main management table of the application. This is a simple interface that enables you to manage the data you've uploaded here to MindSphere and to the application Manage My AI, and to approve these different training requests from the edge devices for AI model training, which will be completed by our team and algorithms that run in succession with Manage My AI. You can see here in the table a range of different edge devices which have submitted model requests, such as the edge devices we've been working with so far. And you can also see examples of which application is sending the data. For example, Analyze MyWorkpiece toolcheck over its application name here, or Protect My Machine setup. Here you can also manage and see the model name which is available. So you can check and see which of the models you have uploaded directly. And also, as a helpful hint, we include the timestamp. So at what point was the data received, and has it been submitted to MindSphere directly. In the status, you will see a number of different options that you can view. So for example, if a model is still pending approval, it needs to be approved for model training, into which state it will then go to in progress or will be underway for training. You may also see that there are failed results within your Manage My AI table. Generally, this message is caused by having an insufficient number of training data available to start the training. Keep in mind that you generally need a minimum of 200 images in order to initiate a training, and it may be that the status has failed because it's not yet been able to start due to an insufficient lack of data. It can also be that there has been some kind of technical issue or a connection problem concerning the ongoing status, and you can always check with your hotline representative if you do receive this message. In general though, when the process runs as planned, you should see your request here as pending approval, at which point we can come through and approve the model. From here you will receive a confirmation, and here as a user you can accept the additional fees that will come with the training hours associated with this model. You can get more information about the training fees and how many hours are generally used for training by reviewing the documentation with your sales representative, and also through the product sheet and specific terms which are directly linked here in the application. Once you're in agreement, all you need to do is check the box and approve the model training. At this stage, you'll receive a confirmation that your training has been purchased successfully and that your training is now in progress. Once the training is completed, you will see an update of the status here in Manage My AI, telling you that your model is now available. And this takes us back to the Fleet Manager aspect. Once your models are available for download, they will then be published as .model files here in the Fleet Manager page of MindSphere. So you simply navigate back to Fleet Manager. Once you've seen that your models are available, you can download the files you need to work with and save them directly on your local device for uploading them to the Edge application in the next step. You can continue to use this process to manage your AI models, maintain the status, approve new trainings, and have an overall picture of which Edge applications have sent which data to Manage My AI. Okay, now that our model is available from Manage My AI, it's time to place it within our SINUMERIK Edge application, Analyze MyWorkpiece toolcheck. We're going to activate it for usage so that we can enable it directly within our automation process. To do this, we go into Manage Models. We see an overview of our models which are available, and we upload from the bottom left-hand corner our model file which we've downloaded. We can select this from our local machine and directly apply it here within the Edge application. During this process, the model details will automatically be mapped to the relevant model here within the model management page. You can see here that it's been mapped again to toolwear demo 3, and we can see via tooltip which version of the model we've updated. Now, we simply toggle the switch to activate the model for usage within the SINUMERIK Edge app. We receive a toast message here at the top once the activation is successful. Now we want to use the model within our process, so we go to Online Analytics on the left. The Online Analytics page shows us a live stream of the camera connection. If we have more than one camera, we can switch our camera view here. We can also enlarge the view and reduce it again by clicking directly on the image. And we can see which models we have on our Edge device, which cameras they're working with, and also activate or deactivate them directly from this page. The Online Analytics page gives you a manual option to activate and use the AI models on the shop floor. For the automated variation, which can be used over G-code, stay tuned in the video, we'll have a look at that soon. If I press this I in the bottom left-hand corner, it will then run the AI model of toolwear demo 3, and we will receive a result based on the training data we provided. Now we see that we have results in our table. The model has triggered the result broken, which is correct as we trained this model based on broken data from this image directly. This information we can also review in bulk here in the reporting page. Here on the reporting page, we can see a number of different details about the activities that have taken place on the device. We can see which model was triggered, what result was given, what type of trigger, if it was done through the application or through the CNC or SINUMERIK, when it happened, and also, if required, who the logged in user of the application was at the time. We can also filter against all of these different result types and also use time-based filtering as well. We can download all this information and the images if required. In addition to this, we also have a helpful dashboarding page, which comes with a custom visualization layout. We can see here over time which kinds of alerts and triggers have been retrieved, how many types of reviews are taking place, the number of results that we have, what the breakdown is between the model variations, and we can also see here again the log of all the different types of model trigger activity that we've had in the application. This gives a brief overview of how to activate and use Analyze MyWorkpiece toolcheck to integrate AI directly on your Edge device. Here you can see a summary of how you can automate the model triggering and model result process directly through updates to your G-code on SINUMERIK. As you can see here, an MGUD or MGUD variable can simply be inserted into your NC program to trigger the activation of a model and also to trigger the results of that model directly within your control environment. This means that anytime you want to trigger the usage of an AI model from Protect My Machine setup or Analyze MyWorkpiece toolcheck, all you need to do is insert the pre-configured MGUD that we reviewed in the Prerequisites video directly into the desired position of your program. For example, if you would like Protect My Machine setup to initiate a workpiece check on rotation or identity before a program takes place, you can put it at the beginning of your program, or if you have intermediate checks, you can also enter the trigger directly throughout the program elsewhere. This same logic applies for Analyze MyWorkpiece tool check using the second variable available here. You can also directly display the results that are triggered by your model in the edge applications by using the Results by mgood option. Here you will see directly within the alarms panel of your device which result has been triggered by your AI model. This result can then be used to trigger further automation processes, such as stopping a process or continuing with a process according to the result that you receive. These steps are very important because they can help to reduce any manual labor involved in the configuration of the process and can integrate artificial intelligence models directly into your production processes. There are also further use cases available for this kind of integration. For example, you can see here an expected string which can be used to automate the data acquisition process by entering a model name ahead of time and also an expected result that's in place. A user can also automate the data acquisition process, which is available manually within the user interface as well. Please consult the user manual further for different details and information on these topics, or contact your Siemens representative if you have any questions. Once you've enabled the trigger and result mgoods directly within your application and within your G-code, you can then see the results as being triggered by CNC or SINUMERIK directly within the edge applications themselves. Here you can see an example from Protect My Machine setup. This logic also applies for Analyze MyWorkpiece tool check.